today we're working on logarithm equations. There's two types we're going to do today, and then there's some more we're going to do tomorrow. First type we're going to do is when there's log on each side of your equations. And then the second type we're going to do is when there's just one log. So if there's two logs, make sure you condense it down so that there's only one log on each side of your equation. And then you can just set what's equal, like what you're taking the log of equal to each other. So here, this is log of 5 and log of 5. And that just means they're going to do the same operation to each other. So you can just set the inside equal to each other. And that's the equation you'll be solving. Subtract over 5x. 9 equals x. Check your answer. You can plug it in and make sure the left side equals the right side. Same thing on this side. Set them equal to each other, just the insides of what you're taking the log of. Let's do, again, one log on each side. So the insides have to be equal. Add over 3w. And check your answer. I know a lot of you like to just be like, I'm not going to check my answer. I'm going to skip it. But logs can't be negative. So if I plug 6 into this equation right here, I will get log of negative 2 times 6. And you can't take the log of a negative number, so negative 12. Because this is a base 10. Remember, the common log has a base 10. Because you're saying 10 raised to some number equals negative 12. And that's impossible. No matter what number I plug in for x, I can't get a negative number. I could get positive 12. 10 raised to a number can equal positive 12, but it will never equal negative 12. So the inside of a log cannot equal a negative number. So since when I plug in 6, I would be taking the log of a negative 12, this is no solution. So this isn't saying your answer can't be negative. This is just saying when I plug it back in, it must be positive. So you have to check your answers. Luckily, you have the nice calculators, so checking your answers isn't too bad. You just plug it in there. Let me pause the video so I can plug it in and show you. All right. To show you, we're going to do log. And remember, log is control x squared. The common base log is 10. But we're doing 9. And then I'm plugging in 6. So 6 minus 3 times 6. Times 6. Can't do it. It gives you a negative under a radical. It wouldn't be a real solution. So nope, not possible. And then you can do the other one with 5. Log base. Puka, stop barking. Sorry, guys. 5, and then the answer I got was 9 plus 9. Number, and then the other side of it, log base 5 of 6 times 9. Yep, those are equal, so you know your answers are. So solve and check for extraneous. I know it's annoying sometimes, but luckily these calculators are nice and easy to check for extraneous answers. All right, let's get into some harder questions where if you have two logs, you have to do your rules to combine them. So here, when I condense this side, it's going to be log base 10 because it's the common log, and it's addition between the two logs. So when I combine them, I'm going to multiply. If there's two terms or more, I put the whole log in parentheses. If it's just one term, like 72, I don't put in parentheses. So log of this number equals log of that number. The log is a feature that will do the same thing. So since they're both log, we're just going to set what's inside to each other. equal. And so then you have 4y plus 20 equals 72. Solve it by subtracting 20. 4y equals 52. Divide over by 4, you get 13. Okay, so sometimes you have to condense them or use your exponent rule. Thank you, Avery. Thank you, Avery. So 3 goes up to the top. So log base 7 of 4 to the third equals log base 7 to a minus 8. They're both log base 7, which will do the same thing to these numbers. So 4 to the third equals 4a minus 8. And that's what you're solving. 4 to the third is 64. 48 minus 8 add over 8. I get 72. Divide over by 4. I get 18. Check your answer. Go back and plug it in. The easiest way to check it. Let me type it in. I'll show you. When you type it in, just always go back to the original, because if you change something and you did something wrong and you find your answer is wrong, it could be something what you did. If you use the original equation, it's obviously not something you did. I said my answer was 18 minus 8. True. All right, moving on. So you can just type this whole thing in with the equal signs. If you don't have the newer calculators or are at home, you can use Desmos to do this. The only problem with Desmos is you have to do log. You'd have to do log of 4 divided by log of 7. And I can show you that if you need to. I'm kind of just bouncing around. Condense so that there's a log on each side, just one log, nothing else. So I'm going to use your power rule to bring that up. This is already one log. So this is log base 3 of 6 squared minus log base 3 of 4. Well, you know 6 squared is 36. So log base 3 of 2p minus 5. And then if you have two logs being subtracted, you can condense that with division. So it'll be 36 divided by 4. So you have log base 3 of 2p minus 5 equals log base 3 of 36 divided by 4 is 9. And then they're both log base 3, so you can cancel this out and do 2p minus 5 equals 9. So 2p equals 14 and p equals 7. Check your answer. And check your answer is correct, so you're good to go. All right. Guess what? We're not done with quadratics. We still have to know how to solve our quadratics. Okay, this is multiplying. So when we're multiplying, we're going to do, when you condense with two logs with addition, it's multiplying. So this is 2k squared. Now we have one log on both sides. So what you're taking the log of can get set equal to each other. Quadratic, when you see k squared, you're going to have to, that is a quadratic, or x squared or m squared, whatever letter squared. That is a quadratic, and you're going to have to solve by factoring. Usually, these are going to be nice to factoring. Quadratic formula. I'm going to probably stick with factoring. Some people loved quadratic formula, though. Graphing. But anyway, when you solve a quadratic, remember you have to set it equal to 0. So I'm going to move these two over, because if I can keep the k squared positive, it makes it easier to factor. So set it equal to 0. I'm going to subtract over k squared. And I'll get k squared equals 16. Subtract over 16. K squared minus 16 equals 0. And then when it equals 0, you factor. This is the difference of squared. A squared minus b squared equals a plus b, a minus b. So k minus 4, k plus 4. Set each of those equal to 0 and solve. So k equals, add over 4, k equals negative 4. And now you have to check both of those answers. And we're going to have to go back to the original. So we're going to do log. You can put base 10, but it's just log of 2. Log. Checking 4, -4. I'll start with 4. Four squared 16. True. And see, it filled in base 10 for me. It's nice. And now I have to check -4. Remember, when you square a negative, it has to be in parentheses because it should turn into a positive. False. So -4 doesn't work. So -4 doesn't work. And +4 does. So this one doesn't work. +4 does. Last one, just to help you practice your factoring a little bit. They're both log base 4, so we can skip that step. Once you see m squared, a quadratic equation, you have to solve by one of these factoring, quadratic formula, or graphing. So get everything on the side with x squared or m squared. Try to keep your m squared positive if possible. Add it over to 7m, subtract it over 18. This is a trinomial, so unlike difference of squares, I have to know what multiplies -18 and adds to -7. You can finish it from here. I just wanted to help you remember how to do that. I am going to check that you finish your notes, so please make sure you finish your notes. The second type of question is condensing and isolating logarithms. So if there's one log on one side and then a number on the other. After you condense it to one log, then you write it in exponential form, solve your equation, checks for extraneous solutions. So it is one log, so write it in exponential. 2 raised to the 6 equals x minus 4. 2 to the 6 is 64. Yep. 64 equals x minus 4. Add over 68 equals x. Check your answer. When you check, you go back to the original. So log base 2 of 68 minus 4 equals 6. Make sure this side equals 6. When you put it in a calculator, it does, so you know your answer is right. So I have to get this log by itself. So easiest thing to do is add over 7. See how that is not in my log equation. So just add it over to the 3, or -3. And 3 to the 4th, write it in exponential. Now that's one log. 4x plus 8. 3 to the 4th is 81. 9 times 9. Minus over 8. I get 73. So x equals 73 divided by 4. Check your answer. Put it in the calculator. Log base 3 of 4 times 7/3 over 4 minus plus 8 out of the log minus 7. We're trying to make it sure it equals -3, and it does. So that's your answer. Okay, if it is not one single log, you need to condense it so it's a single log. Addition condenses down to multiplication. Little parentheses happy, but so I will multiply these. Make sure you're multiplying it to the x and to the 5. 2x squared minus 5, 10. Oh, I said that and then I didn't do it. 10x equals 2. Write an exponential. So 10 squared, because remember common base 10, equals 2x squared minus 10. X. That's 100. This is a quadratic, so we have to solve this by factoring. So I'm going to set it equal to 0. I'm trying to keep x squared positive, so I'm going to subtract over 100. Everything's multiple of 2, so I'm just going to make all my numbers smaller by dividing by the greatest common factor. I ran out of room. I'm doing x squared minus 5x minus 50 equals 0. We'll multiplies to negative 50 and adds to negative 5. 10 and 5 with 10 being negative. So x minus 10, x plus 5. Set them both equal to 0 and solve. So x equals 10, x equals negative 5. And we have to check both of those answers. Well, before we even check it, if I plug negative 5 in here, this is going to be negative 10. So you should know negative 5 won't work because, again, you can't take the log of a negative number. You can't take a log of a negative number. So that one would make a negative number. But you could just put it in the calculator. I'm going to pause the video so I don't waste your time and show you. All right. As you can see, I plugged in 10. I messed up. And I messed up this one because I plugged in negative 5 and it became a multiplication. So just be careful how you enter it. But I plugged in 10, it was true. I plugged in negative 5 and it was false. Again, you can't take the log of a negative number, and both of these logs would have been negative. So that should help you know how to check your answer. Okay, one more. All 14, 15, and 16 you will have to factor. So I'll do one more of those. Let's see, the hardest one. Probably 14, just because it's different. Okay, so exponential, the 2 has to go up here. So log x squared minus log 4 equals 2. Condense it. Condensing is with division. So log with the subtraction of 2 logs is condensed with division is what I meant to say. Over 4 equals 2. Okay, so 10, writing an exponential, base of 10 squared equals x squared over 4. I'm coming, Avery. Hold on. 10 squared is 100. So multiply over 400 equals x squared. You're solving quadratic by factoring. So you have x squared. I'm subtracting over the 400 equals 0. Difference of squares. X plus 20, x minus 20 equals 0. Set them both equal to 0 and solve. Thank you. Negative 20 won't work because if I plug it in, you'd be doing log of negative 20 and you can't take the log of negative 20. When you put it in the calculator, positive 20 does work. Okay, so that leaves you 1, 2, 3, 4, 5, 6 to finish on your own. And then the quizzes. Okay, really quickly, I can give you the answers, but what I'm checking is that you're doing your work. So n equals negative 7. Make sure you do the work right here. Show work for my people who aren't going to watch the video, because I know it's true. 8. Show work. N equals, this is 6. 2. Show work. Whoa, that's not a S. Show work. W equals 9/2. Show work. 2 answers. Hello, little girl. Thank you for coming to me. Show work. X equals 12 and x equals 3. I'm sorry, negative 12. One of these doesn't work. And then this one is also factor. I don't want to make sure we're good with factoring, so I'm not going to give you a hint on that one. Just do your best. Or talk to me about it later. But those complete it. Don't turn it in. I will get it from you later.